This is a standard manual lathe from Sherline, this model, and I really happy with this, but also in addition I decided to make it controlled by PC, so I wanted to connect some step drivers, and I did. To do this I attach this plate, so put some holes here with the threads, and mounted this plate with the bearing, and through this bearing I put the bolt with this cut, and I cut also the slot in this thread and bolted, so it is pretty stiff connected. Initially I created this one from the brass with the hole in the threads, and I fixed this with a bolt, but I had regularly many places, so I think this is more stiff, and I can just unscrew this and remove it. I have this frame with the NEMA 23 motor, and I connect it like this, put it here. It's like a hinge, so it can slightly move or tilt. And then I also put this timing belt on this hinge, and then I can connect this belt between these two pulleys and fix it with the handle. But I also can't make required tension between these two parts, and then fix it. So now the motor actually drives the x-axis, and when I need to work with the manual lathe I just disconnect it, and then I can work with the manual. This is how it works, and I have the connector for this x-axis, and I can disconnect it totally. To run it with the y-axis I created the such brass axis, some I put on the axis, and also fix it on this pulley, timing belt pulley on it, and afterwards I put at the end this wheel for manual controlling. And this is control unit. I can fix the lathe on it like this. It's technically enough just one nut to hold it, because it has more load here. And then on this end I have this statically fixed motor NEMA 23 again, which has pulley, timing belt pulley, and this is just used as a spacer. So I can put the belt with this hinge. I can make the required tension and fix it. And now it works with the controlled by motor, and if I turn it off with the manual wheel. And this is why, with the totally similar connection. And this is the save button, which I can disconnect the motors, and then I can freely control it with the hand, and when I turn it on, I can control it with the motor. The same thing happens to the Z-axis. This is milling column, which I can mount here. Has its own cable with connection, the same connection. Motor, it was already bought this way, ready for CNC, but I still can control it with the manual handle. I can connect only to these three connectors, Z, X and Y. If needed, I can switch Z and Y if it is in some reason needed, and they work with the same ratio. And then we mount here the head, the tails, the stock. Unscrew this chuck and put this collet holder. This is ear 11, I believe. And then I fixed it with this threaded rod. And fixed. This is the standard pulley, and this pulley for timing belt I added for connecting servo or step motor, to use it instead of the default one. Now it is ready to run, so I engaged this axis, the X1, Y and Z, and then I can just take this milling cutter, cut it, connect it, and then we can use the port where it was connected, the control system, open it, connection established, and then I can run. I also have this simple prop. This is 40 millimeters exactly, which I can use stereo or tune with this bolt, swing like this. And then I connect to the ortho prop. Okay. And then it moves to this prop, and then it retracts back on some distance. And if you look at the same moment in the G-code sender, it looks like this. Starting prop, goes down, it hits the prop, and then tries again with the slower speed, and then it retracts. And this is the distance from the prop, but because prop also have some height, I put 40 millimeters here. So now it is on the height 45 millimeters, 58. Now let's see how the control system is built on. This power supply for the step motors, 24 volts, and this power supply for the servo motor, or actually closed loops step motor for 48 volt. Here we have 3 step motor drivers, DM556, and here is the FluidNC basic driver made on ESP2032. This is the model ESP32 and have number of outputs. This all can be disconnected. Remove it. Now I'm going to replace all this with the closed loop step motors. Like one I going to use on the rotary table, which I'm planning to connect now. Now this is stepper motors, NEMA 23, and this is actually control system for each motor, like replacement of this one. But I think it also have the encoder, so it's supposed to be more stable. This motor plus this is equivalent of one this. So if I do this, I can remove all this stuff, so it would be less space needed. I can reduce all this box in size, but now I need to connect one more wire to control this one in this control system. Connected A axis to this rotary table, which can be engaged or disengaged. Or it can be disengaged and rotated manually. There is also this tilting platform. It fixes here, and using those threaded bolts on 3 sides, I put here blank with glued material, and it can be tilted on different directions, so it can be leveled to the 0. It's a pretty simple solution. That's it. Thank you for the viewing.